Hello everyone, this is Balu. Welcome to my channel Civil Cave. In the previous video, we have discussed about eccentric in-plane connection. I am telling that this is in-plane connection because whatever the load which is acting and also the bolts are in the same plane. For example, if you consider this bracket as a plane or board, whatever I am writing is a plane, and it is clear that whatever the load is acting and also these bolts are in the same plane. So I am telling this as eccentric in-plane connection. And we have already converted this whatever the eccentric load to the axial force and also torque. So if I consider this extreme bolt, in extreme bolt there is a two forces are going to act, that is due to the axial force, that is nothing but shear force is coming into the picture, and also due to this torque there is a other force, that is F2 force. So if you find the resultant of this the force, you are going to get the ultimate force which is acting in this extreme bolt. So here whatever the formula for this F2 is nothing but PE into R by summation of R square. For example, if I consider this extreme bolt, R1 is the radial distance from the CG of the bolted group to the center of the bolt. So I have to substitute this R1 in the place of R for finding the F2 force in the extreme bolt. And coming to the summation of R square, here there are 6 number of volts. You can observe clearly. And for 4 number of volts, R1 is a radial distance, that is from the CG of the bolted group to the center of the bolt. And coming to the other 2 bolts, here you can observe clearly, R2 is the distance for other 2 bolts. So 2R2 square is nothing but the whatever the summation of R square for other 2 bolts. So if you combine all the radial distances, you can get summation of R square is nothing but 4R1 square plus 2R2 square. So you have to substitute whatever the summation of R square in the place of this formula to get the whatever the F2 force. And F1 is nothing but whatever the axial force which is coming, and it is equally going to distribute in the each and every bolt. So you have to divide by the number of volts, that is n, to get the F1 force. And resultant force, here you can observe clearly. For example, if I consider this bolt, F1 is a force which is a shear force is going to come into the picture, and because of the torque this F2 is going to be generated, and theta is the angle between these two forces. Then resultant force is nothing but root over F1 square plus F2 square plus 2F1 F2 cos theta. It is by the parallelogram rule of law. And what are the basic checks we have to do for this bolted connection is, because of this eccentric load, we have to check for the shear and also bearing. There is no possibility of tension force in the bolted group. So this is a clear-cut summary of the eccentric in-plane connection. Now let us get into the eccentric out-of-plane connection. Here if you observe, this is a electric pole and this is a transformer which is connected through the bolts clearly. And for example, if you consider this as a bracket, and whatever the transformer, it is clearly welded to this bracket. And if you assume this as a point load, and this whatever the transformer point load is acting through the bracket, and whatever the load is going to transfer into these bolts. And if you observe clearly, this is the plane in which the bolts are there, and whatever the plane in which the load is there is in the perpendicular plane. This is the perpendicular plane, and this is the plane in which bolts are there. And whatever the plane which is perpendicular to the bolts plane is nothing but the transformer lies. So we can call it as eccentric out of plane connection, because both whatever the bolts and transformers are in different planes, absolutely in the perpendicular plane. So it is nothing but out of plane loading. This is a, for example, electric pole, this is a column and this is a bracket, and we can call it, for example, this transformer as a point load P acting at an eccentricity E, and we can assume whatever the practical thing into the theoretical thing, such as this whatever the bracket connection to the electric pole with a point load. So this transformation is very, very important for a civil engineer. You have to convert whatever the practical thing into the theoretical thing, then you have to analyze how this load is going to transfer. Now observe clearly. For example, here whatever the load P is acting, because of this force, what is the force which is going to be developed in these bolts? Absolutely, if you observe clearly, this bracket is going to pull these bolts. So because of this pull, tension force, that is tension is going to act in these bolts. For example, if you assume this is the neutral axis, and whatever the bolts which are above this neutral axis is going to suffer tension force, and whatever the bolts which are below this neutral axis is going to suffer compression force. So this, whatever the bracket, it is going to be pulled outwards in this way. It is not going to rotate, but it is going to be pulled outwards. Because of this pulling force, there is a development of tension in the topmost bolts and also compression in the bottommost bolts. So what are the checks we are going to do? Similarly, whatever the bearing check, absolutely we have to do, and also shear check, and absolutely the final check is nothing but tension. And whenever the bolt is subjected to both tension and also shear, there is a combined check is available in the IS 800-2007. So we have to check for the combined check also. This is an important thing regarding this, whatever the eccentric out of plane connections. And if you consider, this is one of the real life bolted connection. This, for example, if you observe, this is a bracket, and also if you apply the load here, and this is going to be the eccentric out of plane connections. These are the bolts which are going to be suffer whatever the loads coming into the bolts. And this is the isometric view of the whatever the I section. This is assumed as column, and also this is the bracket. And if you apply this load, point load, and these are the bolts which is going to resist the load which is coming due to the eccentric load. Now similarly, which is in the last case, we have derived the equation for the force which is developed in the bolts. In this case also, let us derive the equation for the tension force which is going to be developed in these bolts. Here I am just applying equal and opposite force from the top and also in the bottom, so that if we combine these both cases, whatever the force which is going to be nullified. So for that case, there is a development of the moment in this direction, and also there is a possibility of shear force which is acting along the bolted group. Now we have to convert whatever this moment into the force, tension force in the bolts which is above the neutral axis, and also it is going to convert compression force which are bolts are below the neutral axis. Here you can see whatever the load which is acting at an eccentricity is converted into the shear force, that is nothing but axial force, that is P, and also this is the moment which is developed, that is P into E. Here we have to convert what is the movement into the tension force and also compression force. Based on the trial and error method and also experimental analysis, they have concluded that whatever the neutral axis is going to lie at a distance of 1/7 of the h. What is this h? H is the distance of the topmost bolt center to the edge of this bracket. This is the h. And above this, whatever the neutral axis, this is nothing but the tension force is going to act, and each and every bolt is having certain tension force, and also whatever the force which is below the neutral axis is nothing but the compression force, and whatever the bolts below the neutral axis is going to resist the compression force. So for example, if you consider, this is T1 is a force which is developed in the topmost bolt, and Y1 is the distance from the neutral axis to the topmost bolt center. Similarly, in T2 is a developed force, and also T3 is a developed force, and corresponding distances are Y2 and Y3. So let us derive the equation for the tension force in the bolt. Here, whatever the tension force which is going to be developed, it is directly proportional to the distance of that particular bolt from the neutral axis. Here you can see clearly, that is whatever the topmost bolt is going to suffer more tension, and whatever the distance from the neutral axis is maximum in case of this topmost bolt only. So this T is directly proportional to the distance from the neutral axis, And if I remove this proportionality, you will get the constant, that is K. Now what is the K? K is nothing but Ti by Yi. Ti is nothing but the tension force which is developed in the ith bolt. Now you all know whatever the movement that is which is developed due to the tension force is nothing but tension force into the lever arm will give you the whatever the moment. And if I substitute the Ti value, that is nothing but K into Yi in this equation, I am going to get K into Yi square. Now whatever the moment which is developed, that is nothing but P into E, and this particular P into E moment is going to be converted into tension force moment and also compression force moment. So we can say that this total moment is equal to the tension force moment plus compression force moment. Here I am writing total moment of resistance due to tension. So here total moment of resistance due to tension is nothing but summation of K into Yi square. That means here whatever the bolts which are above the neutral axis, those bolts are going to resist the tension force, and each and every bolt is having certain tension resistance. If you add all those whatever the tension resistance, then it is going to give the total moment of resistance due to tension. So I am keeping out whatever the constant outside and summation of Yi square. I already said that is Yi square is nothing but Y1 square plus Y2 square plus and summation of all whatever the bolt distance from the neutral axis to the centroid of that bolt. And in place of constant K, I am substituting here. I have already written K is nothing but Ti by Yi. I am substituting here Ti by Yi into summation of Yi square. And here if you convert whatever this equation, you will get the tension force. Here Ti is nothing but M1 into Yi by summation of Yi square. Now if I write this equation for the critical bolt, T critical is nothing but M1 into Y1 by summation of Yi square. Yn is the distance of that critical bolt from the neutral axis to the centroid of that particular bolt. And if you observe carefully, what is the critical bolt is going to be? The critical bolt is going to be the which is at the utmost periphery of the top bolt. That means the bolt which is at maximum distance from the neutral axis is going to suffer more tension. And similarly compression force, we all know for the equilibrium whatever the tension force which is going to develop, it must be equal to the compression force. Then only the whatever the system is going to be in the equilibrium condition. Otherwise it is not in the equilibrium condition. Whatever the tension force which I have derived, that is nothing but also equal to the compression force, because for equilibrium both must be equal. So M1 into Yi by summation of Yi square. I already told whatever the external moment which is developed is nothing but summation of tension moment plus compression moment. So tension moment which I already explained is nothing but M1. I am writing here this M1, and also compression moment is nothing but compression force into the lever arm, that is Y bar. Here Y bar, here you can see this is the triangle which is the force triangle of the compression force. From the neutral axis, the centroidal distance of this compression triangle is nothing but the lever arm. So if you consider this triangle whatever the centroid is located 2/3 of the whatever the height of this triangle, that is h by 7. Here that important thing is, it is assumed that the whatever the neutral axis is going to be located at h by 7 distance. So 2/3 of the h by 7 will give you the 2h by 21, which is a lever arm for the compression force. I am substituting here. Here Y bar is nothing but 2h by 21, and I am taking out common, that is M1. You can observe clearly, and I am going to get whatever the M1. M1 is nothing but the moment of resistance, which is you have to substitute to get the tension force in the tension force equation. Here total external moment is nothing but total P into E is going to be the external moment. Through this equation you are going to get the M1 value. If you substitute this M1 value in the tension force equation, you are going to get the critical tension force in the critical bolt. So I already derived whatever the equation for the tension force, that is nothing but m1 into y1 by summation of yi square. So m1 is already derived, that is nothing but m by 1 plus 2h by 21 into summation of yi by summation of yi square. M is nothing but the total external moment, that is load into eccentricity E. Here you can see this is a P and this is a E. And coming to the shear force, this shear force is going to be transferred equally to the each and every bolt. So we can divide the total force by the number of bolts so that you can get the shear force in each and every bolt. Now what are the checks we are going to do is nothing but first check is tension and next check is shear and third check is bearing. These are the three important checks we have to do for these bolts which are subjected to the eccentric out of plane force. And this is the summary of the eccentric out of plane connection in which the load is acting at a eccentricity E. Thank you for watching this video, and also if you have any doubts, please comment in the comment section. I am going to solve, and also if you want any content regarding any other steel or any RCC also, please comment in the comment section so that I try to do videos on that concepts. Thank you.